Good afternoon all. Myself is Vigneshwari, Assistant Professor in the Department of Electronics and Communication Engineering from SNS College of Technology. So today I am going to take topic on multiplexer from the unit combinational circuits under the subject digital principles in computer organization. So basically what is a multiplexer? So multiplexer, it is a combinational circuit, can also be referred as a data selector line that consists of 2 power n inputs. That is, it consists of many inputs, and based on the control line or the selection line, the output will be connected to one of the respective inputs. So it is a combinational circuit which selects one input from multiple data inputs and forward that over a single communication channel, right? So basically there are different types of multiplexer where we can see about one after the other. So let's start with 2 is to 1 multiplexer. So 2 is to 1 multiplexer is, it comprises of two data inputs I0 and I1, and the selection line is S, and accordingly it will connect the output Y to the respective input data input, either I0 or I1. So when we say as 2 power n input, the n represents the selection line, right? So based on the selection line, the output Y will be connected to one of the data inputs present in the input cell. So here we can see the truth table of a 2 is to 1 multiplexer. When the selection line S is equal to 0, the output Y is connected to I0. When the selection line S is equal to 1, output Y is connected to the data input I1. So here it connects to 1 bit data sources to a common destination. Next comes with the 4 to 1 multiplexer. So here 4 represents the 4 data inputs and 1 represents single output line. So for 4 data inputs are I0, I1, I2 and I3. And the selection lines are S1 and S0. So since here are 4 data input, the selection line is 2 here. So based on the selection line, the output will be connected to one of the 4 data input. The Boolean expression for 4 to 1 multiplexer is S0 bar S1 bar I0 plus S1 bar S0 I1 plus S1 S0 bar I2 plus S1 S0 I3. So from the truth table, we are deriving this Boolean expression for 4 to 1 multiplexer. So when selection line S0 and S1 both are 0, output Y is I0. When the selection line S0 is 1 and S1 is 0, the output Y is connected to I1. When the selection line S0 is 0 and S1 is 1, output is connected to I2. And when S0 and S1 both are 1, the output Y is connected to I3. So the 4 is to 1 multiplexer of the Boolean expression related in the previous slide, it can also be implemented using a basic logic gates, AND gate, OR gate and the NOT gate. So here it comprises 2 NOT gate and 4 AND gate and 1 OR gate. The multiplexer analogy is similar to a different railway tracks leading to a common destination point. Based on the control lever you choose, the train from the different track maybe like a D0, D1, D2, D3. The train from the respective track depends upon the control lever position as to which train will be directed to the output D. Right here, the control of lever position it decides is related to the selection line S0 or S1 accordingly. 8 is to 1 multiplexer comprises of 8 data input and 1 output. Right, the 8 data inputs are being split as 2 4 is to 1 multiplexer combination for implementation. So the data output from the 2 4 is to 1 multiplexer is being provided as an input to 2 is to 1 multiplexer, and based on the selection line, the data from the 2 to 1 multiplexer it directs one of the 8 data input to the output signal Y. So it comprises of 3 selection line and 8 data input line, and based on the 3 selection line, the output Y is connected to one of the 8 data inputs respectively from I0 to I7. The 16 is to 1 multiplexer has 16 data input lines and 4 selection line, and that can also be implemented using two 8 is to 1 multiplexer in the first stage, and the output of those two is to 8 is to 1 multiplexer is being connected as an input to 2 is to 1 multiplexer in the second stage. So based on the selection line, the data input from I0 to I15 has been directed to the output signal Y. So the 16:1 multiplexer, it comprises of 4 selection line and 16 data input line. So as we say, 2 power n input line comprises of n selection line, and based on the n selection line, the output Y is being decided accordingly. Advantages of multiplexer. So multiplexer is basically has a good efficiency compared to in the combinational logic circuit. It can also be referred as a data selector lines. So the circuit is easier to implement using the basic gates where it reduces the chip area and wiring. So this efficient and flexible, and this can be used for implementing any boolean function. The drawback of such multiplexer is based on the selection line, the number of inputs are being restricted, and hence a short delay will be there as the input grows complexity. So when the complexity of the input arises, it is harder for designing the hardware side and also needs decoders also. And it also consumes more power and adds a circuit complexity. Next comes with the application of multiplexer. So multiplexer is efficient for data selection, and it is used in analog to digital converter for choosing the analog input channels, and it is used in decoding, address decoding for microprocessor and also for memories, right? And the assessment questions are being discussed in the slide. So kindly go through the video for answering these assessment questions, right? Thank you.